Hi guys, the point of this video is to just clarify some questions or some confusion we might have had, especially for the last few slides, how to do some of the problems and how it relates to the project. I flip-flopped some of the words when I was talking about um, what the questions were asking, what I was expecting. So I was rushing, try to get it out to you because I had taken such a long time on the first part and wanted to get this to you by a certain time, but it's a life lesson there. Anything worth doing right is not worth rushing. So I'm not going to rush through it, but I'm going to quickly review this particular slide here, which relates directly to understanding the questions in the project. So it starts off by saying Paxton Emporium buys graphing calculators wholesale for $100 each and then resells them for 10% more. So write in equation 4 and determine how much Paxton Emporium sells the graphing calculators for. So the whole idea of this is we should have gotten, if we had gone through the other slides and understood what it was teaching us, we would understand that to find how to get 10% more of something, we would combine that 10% more with the original 100%, giving us 110%. So we are trying to find 110% of $100. And in our equation, which has our equal sign, has something on both sides that are balanced, and since it's an algebraic equation, has a variable. I actually want to rewrite that 110% and one as a decimal or as a fraction. I'm just going to do decimals here. So it would be 1 and 1/10 times 100 equals x, which we could solve out to say 110 equals x. And then, as always, we want to try to get in that habit of rewriting the answer at the end to make sure it's very clear. So I would say Paxton Emporium sells the graphing calculators for $110. Now, the second part of the question relates to what I'm going to be asking you in the project. Because here it says on April 1st, Paxton Emporium will have a 10% sale on their graphing calculators. Write in equation 4 and determine how much they will sell for. So, if you're having a 10% sale, that means 10% off. So that means you'll actually be paying for 90% of the amount. So 90% of $110, which we would rewrite as 9/10 times 110 equals x. So x equals 99. And then, so with a 10% discount for the graphing, with a 10% discount, the graphing calculators will sell for $99. Notice I changed the color of this right here, and I'm looking up at this amount right here, and we'll notice they're not the same amount. So we increase by 10% and then decrease by 10% of the new amount, and that number, that $99, does not match how much Paxton Emporium originally bought the calculators for. So your project is going to be asking you questions like, how much will you need to decrease it by to get back to that original amount, in this case $100. This page here is essentially the same as what we just did, but it's using a variable instead of the $100. So it's page 515 in your textbook. Suppose the membership of a club increased by 10% and then decreases by 10% of that new amount. Is the membership back where it started? So if the membership was originally M, so we use M instead of $100 like we did for Paxton Emporium, then after 10% increase, we know it would be 110% of M. And then the 10% decrease means that it's 90% of what it was after the increase. So this right here, this is at 110% M. So we're doing 90% of the 110% M, which we would rewrite as decimals, 9/10 and 1 and 1/10, which we would solve out to be 99 hundredths of M. So the same as 99% of M, and that's 1% less than what it was to begin with, because what it was to begin with was 100% of M. 100% meaning equal to that original price, 100%, the whole amount. So the next thing we want to do is we want to find out, well, how much would we need to decrease it by to get back to the original amount? So that's what we did here. If the original amount was increased by 10%, how could we figure out how much the new amount would need to be decreased by to get back to that original amount, to get back to that M? So I created an equation. It's, I think, a little complicated looking, and I think that's what's maybe confusing some of you. The idea here is that we had 110% of M, and we want to figure out what to multiply it by. I chose a question mark simply because we're not really used to solving equations with more than one variable yet. And then I want some unknown number, some unknown amount, times this 110% M will get us back to 100% M, the original amount. So I rewrote that, took out the percents, changed it to decimals. You could have done fractions if you wanted, to say the unknown amount times 1 1/10 M equals 1M, or just M if you'd rather. So what we should know from our fact families or from our one-step equations is that to get this unknown amount, this question mark, all on its own, I want to undo this multiplication here, so I'm going to divide by 1 1/10 M on both sides. If I divide it on this side by that, it'll cancel it out, because 1 1/10 M divided by 1 1/10 M should equal 1, and 1 times this unknown, this variable, this question mark, 1 times anything equals that anything. So this unknown amount equals 1M divided by 1 1/10 M. The M on the top and the M on the bottom cancel out, because M divided by M equals 1, and 1 multiplied by anything doesn't change that amount. So we end up getting this unknown number equals 1 divided by 1 1/10. Could do that in your calculator if you wanted, which equals 0.909090, going on forever, or 0.90 repeating. I could say that is about, if I wanted, that's what these little curved equal signs mean, about 91/100ths, which I would then say is about 91%. So 91/100ths, that's this here, times 1 1/10 of M equals M. All I did was figure out what this unknown number here was, and I just restated it by putting that in where the question mark was. So I know 91% of 110% of M gives me 100% of M. But that's not quite what the question was asking. It wants to know how much we would need to decrease by to get back to the original amount. So if 91% of 100% of M gets us back to where we started, that would be a 9% decrease. 100% minus the 91%, giving us that 9% decrease. So that is the answer to our question. Okay, so let's look at the questions again for the project, and really take a moment to take notice of the order that it says increase and decrease. So what we just reviewed was what to do if there's a 10% increase followed by a 10% decrease. Notice question A says, suppose an original price is reduced by 20%. By what percent must the sale price increase to get back to its original price? We did increase then decrease, which it went up and then it went down. This question is saying, well, what about if it went down and then went up? I was really hoping that you guys would carefully read and take note of that and try to problem solve on your own. That's what a lot of this was about. However, since there were so many questions about this particular part, I'm going to go over a question which might help clarify. And then I think C was especially confusing, especially when I read the question to you. I didn't clarify some parts. I think I may have said increase when I meant decrease, that sort of thing. So, but first we're going to take a moment to look at A. If you'll recall, I had the Paxton Emporium problems where first there was an increase and then there was a decrease. Well, let's imagine a problem where its price is reduced and then increase. So the opposite. So imagine Paxton Emporium normally sells math textbooks for $100. They're having a 10% off sale and selling the books for, well, if it's 10% off, that means they're selling for 90% of something, and 90% of 100 would be $90. So let's take that. And then I'm really going to break apart the question C because I think there are several parts of it, and I think I kind of mushed some of the words up too when I was explaining it to you guys, and didn't really make it very clear to what I was expecting. So first, we're going to take a moment to look at this question here, which in the Paxton Emporium question I had earlier, it asked what we would do if you had an increase and then a decrease. So here I'm going to give a question where first we're going to have a decrease and then the increase. So the order will be flipped in what we're going to be doing. So imagine Paxton Emporium normally sells math textbooks for $100. They are having a 10% off sale and selling the books for, well, if it's 10% off, that means 90% is left that you're going to pay for it. So 90% of $100 is $90. And if you buy the books and then want to resell them for $100, the original price, what percent have you increased from the sale price? So what percent do you need to increase to go from $90 to $100? So first we have this equation here, some unknown amount that you're going to increase from 90% of 100. Remember, 90% is after the 10% decrease going down. So rewrote that with our decimals, some unknown amount times 90% or 9/10 of 100. In the other problem, remember instead of 100 here, we might have had an m, we had a variable. Sometimes I think using numbers instead of the variables helps us understand the problem a little better. When dealing with percents, 100 is probably one of the best numbers to use because remember, percent means out of 100. And then it's easy to sort of say, well, 90% of 100 is 90. So we're saying what number times 90 equals 100? Remember to undo this multiplication. We're going to divide both sides by what we don't want on this side anymore. And we don't want any numbers. We want this unknown all on its own. So we're going to divide both sides by 90, giving us the unknown amount is 100 divided by 90, which is 1 and 1 repetend, or repeating, which is the same as saying, or roughly 11%. Oops. Look, I made a boo-boo already. Not 11%. Same as roughly 111%. Because remember, if I want to change it from a decimal to a percent, I should be moving that decimal place over 2 places. All right, so we would remember that 111% means the original amount, 100%, because that is one whole, the original amount, and 11%. So our answer to this question would be 11% is the amount that you would need to increase to get that sale price. So this is the method I had really hoped you guys could try to, you know, struggle through because I think that's very important, and I've taken note of those of you who have. Um, but then apply this concept to A when it's asking about 20%, a reduction of 20%, and then how much do you need to increase by 20%. B is still very straightforward. You need to explain why the amount that you reduce and the amount that you increase it back up is not the same, why they're not equal. Okay? And then C, this is where it gets a little confusing because there are multiple parts. Now, in the examples I did originally, we talked about an increase followed by a decrease. This particular question is asking you to do a table for a decrease followed by an increase. What I showed you for question A. So you're supposed to be filling out a table and filling out if you decrease a price by 10%, how much must you increase it by in order to get back to that original amount. So you actually had an answer sheet that I handed out, which should look like this. And we had these numbers up here, how much you decrease by. And then you should have solved to figure out how much you would need to increase to get back to the original amount. Together, we already figured out that this was 11%. So that's what you would fill in this box here in order to show that you figured out. If you decrease the price by 10%, you need then to increase it by 11% to get back where you started. This won't count as your completed work. However, if you just fill this out, you also, like I said, need to show all of your work. So show the equations, or even if you didn't do equations but you figured it out some other way, show that work on a separate piece of paper or on the back of this answer sheet if necessary. Then what I really wanted you to do was try to figure out if there's some sort of pattern that you can use, maybe a formula, maybe just explaining how you use the various equations to calculate how you would get back to the original price. If it's first decreased by X, an unknown amount, and then increased by that unknown amount. But then here's the second part that says, does the same rule apply if you increase first and then decrease? So they're asking if you increase an amount and then decrease an amount, that particular pattern to get back to the original amount, is it the exact same as if you decrease an amount and then increase the amount? So if you go up and then down, is it going to be the same rule, the same pattern as going down and then up? Now, for your charts, if you guys got a little confused and you did, instead of doing where you do a decrease and then an increase, if you flip-flopped them and you did, and you said, okay, well, if I increased it by 10%, I would need to decrease it by 9%. If you filled out your chart that way, as long as you note it, I'll give you full credit. Now, if you did both charts, if you did a decrease and then an increase, and then the one where you did an increase and then a decrease, if you did both those charts, I will give you extra credit for that. Now, I'm sure this is very confusing, saying increase, decrease, just kind of flipping back and forth, but that's one of the reasons that you need to pause it, really try to figure it out, go back over, re-listen. I really appreciate those students who came in and said, I don't understand this particular part. Or even if you had a parent say, you know what, I have a question about what this means. That tells me that you have really listened to the information, you've taken the notes, you've tried to solve it. And then once you've tried to solve it, you've come back to me and you said, you know what? This is where I'm getting confused. Can you help me on this part? Because that's what I really want out of you guys is for you to be problem solvers, for you to persevere through the difficult part, because that's how you're going to learn. You will remember so much more if you figure it out. You figure out the patterns and then you explain it to me and we verify and we make connections together. But if I just tell you every single step along the way, it's just going to kind of go in one ear and you might remember it for a little while enough to take the test and then it's just going to go out another ear. The math is about you noticing those patterns, about you practicing so that those patterns are more automatic. But then, even if you don't necessarily have everything down where you can get it instantly, you understand the connections enough that you can figure it out. That's what I want from you guys as mathematicians. So, again, this project, even if you don't get everything perfect, if it's not 100% correct, I'm grading on. Did you take responsibility for your own education? Did you record the notes? Did you try the problems? Did you explore and persevere and work hard through trying to make connections and trying to solve the problems? That's what I'm looking for. So even if your chart's not perfect, even if you can't quite figure out if the rules are the same, you won't lose points on that as long as I can tell through you showing me the work, um, through you really being able to demonstrate that you tried this. Then you'll get 100%, even if maybe all of your answers weren't technically correct. All right, you guys, I extended the due date of this. I'll still make it work for this quarter's grades because these packets weren't necessarily passed out to all of you when they were supposed to be. And if you need an extra copy, you can find them on Edline under assignments. They're two separate documents. One's got the answer sheet with the chart, and one has the packet where you're going to do the notes. All right, you know, and again, we have this weekend. Ask me questions in the comments under the video. Classcraft, email, find some way to get in contact with me if you have a question. Remember, you can do this. You just have to persevere. All right? Challenges are worth it because in the end, you'll understand it so much better. All right, I'll see you guys Monday.